Hello everyone, welcome back to my YouTube channel VK Classes. Students, you studied in class 9th the law of conservation of mass. Try to recall the definition. That is, mass can neither be created nor destroyed in chemical reaction. It means the total mass of the elements present in the product of the chemical reaction has to be equal to the mass of the element present in reactants. Or in another form of the definition is the number of atoms of each element remains the same before and after a chemical reaction. By knowing this law, hope you understood why we need to balance a skeletal chemical equation to balanced equation. So, let us study balancing a chemical equation step by step. Before we should learn about balancing a chemical equation step by step, we must see an example for chemical equation. Let us see. We did in previous video one activity, that is when zinc reacts with dilute sulfuric acid, forms zinc sulfate and formation of hydrogen gas. The molecular chemical equation for this Zn plus H2SO4 forms zinc sulfate plus hydrogen gas. Let us examine the number of atoms of different elements on both sides is there given in the table. We need to make a table like this with 3 columns. In the first column, elements right involved in the chemical equation, those are zinc, hydrogen, sulfur and oxygen. The next column of the table is number of the atoms in reactant, that is LHS. We should make the balance. Number of elements should be in LHS, the same number of should be in RHS. Then the third column of the table is number of atoms in product, that is RHS. Then let us see the zinc first element in reactant has 1 atom, the same in product 1. As the hydrogen also in LHS side reactant has 2 atom and the product have 2 atom. The same sulfur also number of atoms in reactants is 1. The number of atoms in product is also 1. Last element involved in chemical equation is oxygen. See in the LHS side also 4 atoms as well as RHS side product also 4. Let us study how to balance a chemical equation by taking one example, that is rusting of iron step by step given in your NCERT textbook. Rusting of iron. When any article of iron metal kept out or exposed to open atmosphere, it reacts with water in the form of humid or moisture and with the oxygen present in air. It forms brown color layer is called rust. The process is called rusting of iron. As you see in the picture, iron article rusting exposed to open atmosphere. Let us try to balance the following chemical equation when the iron article reacts with water to form ferric oxide and hydrogen gas. Iron article is ferrous Fe, water molecular formula is H2O, forms iron 3 oxide, that is Fe3O4 by the formation of hydrogen gas. This chemical equation is completely unbalanced chemical equation because you just check LHS side and RHS side, the number of atoms are not equal on both the side, hence it is skeletal form of chemical equation or unbalanced form of chemical equation. Let us study the step by step how to this chemical reaction is to be made balanced one. Step 1. To balance chemical equation, first we need to draw boxes around each formula. At any condition, do not change inside the boxes while balancing the chemical equation. Step 2. As we saw previous balanced equation with the help of table, the same list the number of atoms of different elements present in unbalanced equation. But here let us see one ferrous atom in reactant, 3 atoms in product, 2 atoms of hydrogen in LHS, 2 atoms of hydrogen in RHS. The same 1 oxygen in LHS but 4 in RHS. Step 3. Then what is the best convenient method to start balancing a given equation? That method is to find which compound contains the maximum number. It may be a reactant or a product. So we found in RHS side compound, that is ferric oxide. In that oxygen element has 4 atoms but only 1 atom in LHS. So we need to balance first with oxygen atom. Let us draw a table of oxygen atom. In the table, atom of oxygen in reactant and in product. The initial atoms present in water molecule 1 in reactant, 4 in product. Then we need to balance oxygen atom both the side. We need to multiply 4 oxygen atom to be balanced. So we need to write 1 into 4 in reactant side. But to equalize the number of atoms, it must remember that we cannot alter the formula of the compound or element involved in the reactions, because we did already square box in the step first and know it. The coefficient of that 4 multiplied with 1 atom oxygen in reactant, it should be wrote 4H2O but not H2O4 or H2O bracket square. So it becomes partial unbalanced equation. Iron 4 into water molecule forms ferric oxide and hydrogen as it is. Step 4. Why should we call partly balanced equation in step 3? Because iron and hydrogen atoms still not balanced. So consider any one of these elements to proceed the further. So we will take hydrogen atom. Draw the table for hydrogen atom. In reactant side, atoms of hydrogen are 8 in the 4 molecule of water. In product side, atoms of hydrogen are 2. So we need to balance in product side by multiplying 4 atoms in with 2 in hydrogen. Then the equation would be Fe 4H2O. It produces ferric oxide plus 4 hydrogen atom, where in step 3 there is no hydrogen atom to be balanced. So 1.7 equation is also called partly balanced equation. Step 5. Already we balanced oxygen and hydrogen. Then it is turned to the last element. So pick up the third element, that is iron. Atoms of iron initially 1 in iron, 3 in ferric oxide in product side. So we need to balance reactant side 3 more elements. See, 1 in iron, 3 in ferric oxide. Then the balancing by multiplying 3 to equalize iron atom. So the equation should be 3 iron, here no 3 is there. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both the side of the equation. 1.9 is said to be balanced chemical equation because 3Fe plus 4H2O give rise to Fe3O4 plus 4 hydrogen atom. It means the number of atoms of elements on both the side of equation 1.9 are equal. This equation is now balanced. This type of balancing chemical equation are called hit and trial method. In this type of hit and trial method of balancing chemical equation, we make number of trials with the smallest whole number coefficient. As above, we balanced firstly ferric oxide with oxygen atom, next with hydrogen, both multiplied with to make balance 8 hydrogen in reactant side, and the last element iron also in product side 3 was there, in reactant side 1 we multiplied in reactant side with the number 3. So multiplying with the whole numbers with 4, 1, 3 with the smallest whole numbers to make balanced chemical equation, we need number of trials. So is called hit and trial method. Step 7. Writing the symbols of physical state. It is one more important step to know. Just compare the equation 1.9 and 1.10. Does any change you observe? If no, then carefully examine the above balanced equation 1.9. Does this equation tell us any about physical state of each reactant and product? No. Information has been given in this equation about their physical states like this: solid, gas, solid, gas. What these are, let us see next. I came across many times there is a question frequently appear in the exams or question bank is give reason. Question is why we need to write symbols of physical state. The answer for this, just observe the above equation which is written with symbols of physical states, which is to make a chemical equation more informative, the physical state of the reactant and product are mentioned along with their chemical formulae is the answer for that give reason question. Then what are those physical states? The gaseous, liquid, aqueous and solid states of reactants and product are represented by the notations as gaseous in bracket wrote G, liquid in bracket L, aqueous in bracket AQ, and for the solid states in bracket as S. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and below the arrow in the equation. For example, let us see some chemical equations. When carbon monoxide reacts with hydrogen at the condition of 340 to 400 atmospheric pressure, there forms methanol or methyl alcohol. Let us consider another best example as you studied in your previous class, that is the reaction of photosynthesis. When 6 molecule of carbon dioxide in aqueous form reacts with 12 molecules of water in presence of sunlight and the chlorophyll present in green leaves forms the glucose in the form of food. It releases 6 amount of oxygen along with 6 molecules of water. Here the sunlight and chlorophyll are necessary for the chemical reaction to form glucose under photosynthesis process, and above equation when carbon monoxide and hydrogen must make methanol at the pressure of 340 atmospheric pressure.